Hey students, today's lesson is on zero and negative exponents. We'll start with some key ideas. For any non-zero number, a to the 0th power equals 1. So for example, 4 to the 0th power would be 1. X to the 0th power would be 1. We know that based on the quotient of power property, if we have a numerator and a denominator with a power in both with the same base, so for example, if we had x to the 5th power over x to the 4th power, we know we would simplify that by subtracting the exponents. If we have the same number in both the numerator and the denominator, so let's say x to the 4th power over x to the 4th power. Based on the quotient of power property, we know that would be x to the 0th power, which is 1. And we can also tell by looking at this that if we have the same thing in both the numerator and the denominator, our quotient would be 1. On that same token, the power 0 to the 0th power would be undefined because we can't have 0 to the 2nd power over 0 to the 2nd power, because that would be 0 divided by 0, and we know that anything divided by 0 is undefined. So that's why it needs to be a non-zero number. On the other hand, for negative exponents, for any integer n and any non-zero number a to the negative nth power is the reciprocal of a to the nth power. So here we have an example. 4 to the negative 2nd power is the same thing as 1 over 4 to the 2nd power. Again, if we think of this in terms of the quotient of powers property, let's say we have x to the 3rd over x to the 5th. Based on the quotient of power property, that would be x to the 3 minus 5, or x to the negative 2nd power. And if we write this in expanded form, we have x times x times x over x times x times x times x. Oops, what's going on? Times x times x. Let's see if I can get this fixed. There we go. And as we simplify that, we could cross off x divided by x 3 times, because anything divided by itself is 1, and we're left with 1 over x squared. All right, so let's look at some examples of this. We're going to evaluate some expressions first. So 3 to the negative 4th power, because this is a negative exponent, we're going to say that's the same thing as 1 over 3 to the 4th power. And then we'll go ahead and simplify that. 3 to the 4th power is 3 times 3 times 3 times 3, so 9 times 9, 81. 1 over 81. All right, for this next one, we'll go ahead and use our product of power property to say both of these powers have the same base. So our exponent would be negative 4 plus 4, which is 0. So negative 8.5 to the 0th power, which is 1. We want to think about this in expanded form. This negative 8 to the negative 4th power would be 1 over negative 8 to the 4th power. So we would basically have negative 8.5 to the 4th power over negative 8.5 to the 4th power. So that's another way to think about this, is how we would get to a simplified expression of 1. Then C, we're going to use that quotient of power property to simplify. Both of these powers have the same base. So this is 2 to the 6 minus 8, so 2 to the negative 2nd power. That's the same thing as 1 over 2 to the 2nd power, or 1/4. All right, let's look at a few more examples. Here we have negative 5 times x to the 0th power. Keep in mind, there's no parentheses around this negative 5x, so we have two different factors here, negative 5 times x to the 0th power. Okay, so that's going to be negative 5 times 1, which is negative 5. On our next example, we have 9 times y to the negative third power all over y to the fifth power. So I'm going to simplify this by saying 9 times y to the negative 3 minus 5 power, so that's to the negative 8th power. And then when I look at what the power actually is, this is really like 9 times y to the negative 8th power. The 9 is not being taken to the negative 8th power. So the 9 is going to stay in the numerator, and the y to the 8th power will be moved down to the denominator. So it's 9 over y to the 8th. All right, let's look at a real-life application. It says a drop of water leaks from the faucet every second. How many liters of water leak from the faucet in 1 hour? So let's first convert 1 hour to seconds. So we're going to say 1 hour is 60 minutes. So we'll use that conversion rate. And then 1 minute is 60 seconds. So if I multiply all the way across, that's 3,600 seconds. All right. Now, if we know that a drop of water leaks every second, we need to multiply our 3,600 seconds times the volume of a drop of water, which is 50 to the negative second liter. So we have 3,600 seconds times 50 to the negative 2 liters per second, because it's 1 drop of water every second, and here's the volume of a drop of water. So that means we need to do, let me move this down a little bit so I've got room. 3,600 times 1 over 50 squared. Okay. So that's 3,600 times 1 over 2,500. And I can rewrite that as 3,600 over 2,500. We know that 2,500 would go into 3,600 one time, and we would have 11,000 left over. So that's 11,000 over 1,100 over 2,500. So that's 1 and 11 over 25, and we're left with liters as our units. So how many liters of water leak from the faucet in 1 hour? 1 and 11 over 25 liters, so almost 1.5 liters. All right, that's it. Go ahead and try a few on your own. I'll see you soon.